So in this video, I want to go through some examples of simplifying expressions that involve surds. Now, surds as a topic and the simplification of surds, rationalised denominator, all of that, is identified as higher GCSE maths material in the current specification. However, this part is identified as higher end foundation material. So essentially you're not having to do any of the simplification of a surd or rationalising the denominator, none of the more complicated bits. It's just really understanding what the square root symbol is in relation to squaring, for example, and how you can simplify that, which I'll be showing you in this video through these 4 examples, and also just some collecting like terms, which I'm going to show you here as well. We'll go through some examples of working with single brackets and double brackets in the next 2 videos as well. So, first of all, question number 1, we have the square root of x all squared plus the square root of y all squared. Now, what you need to understand is that square rooting and squaring are inverse processes of one another. So they reverse engineer each other. So if you square root a number and then square it, you get back to where you start. Or if you square a number and then square root it, you get back to where you start. So essentially, if I'm square rooting and then squaring, all I'm going to be left with is just x. Okay, so it would be like saying if x was, let's say 4, then if I square root 4, I know that that is 2. And then if I square it, well, I'm squaring 2, and 2 squared is 4. Okay, so that's essentially what's going on here, which means that this just simplifies to x, and this just simplifies to y. So this expression is just x plus y. Now, if we do a similar thing with number 2, here we have 3 root x all squared. Okay, so what you need to be clear on is that the squaring affects both the 3 and the root x. Okay, so consider what happens to the 3 first. Here we have 3 squared, which is 9. And then we have the root x all squared, which from the previous example we just got x. So this is 9x. With number 3 we have root 5x plus 5 root x all squared. Now let's leave that alone for the moment. Can't do anything with that. Let's look at this term. Now, just as it was in the previous term, focus on the 5 first. That squaring has got to affect both terms, or both factors I should say. 5 squared is 25. And then we have the square root of x squared, which is x. So we have root 5x plus 25x. Now, this is something that you could simplify a little bit further by factorizing. So this we can factorize into a form where you've just got it in terms of x. Well, it is just in terms of x, but what I mean is you just have a bracket, lots of x, which is often a neater form to write it in. I know this says expand and simplify, but it may be neater actually to write it in a form where we have something times x. Okay, so we pull x out as a factor. And all it is if you divide that by x, you get the root 5. And if you divide that by x, you get the 25. So that's all it is. And then you've got something times x. So that's a nice, neat form to have it in. Number 4, we have 3 root 2x, take away 8 root 2x, take away 2 root x all squared. Now the first thing I'm going to do is focus my attention on those first two terms. Okay? Now, if this was 3x, take away 8x, then my answer would be minus 5x. So here you have 3 root 2's, and you're taking away 8 root 2's. So I'd be left with minus 5 root 2's. So it's minus 5 root 2x. We have collected those like terms together. So we've dealt with those two. If we focus on this one now, in much the same way as we had here and here, we have 2 squared, which is 4, and then root x all squared, which is x. And then again, just as we had here, we can factorize the x out and have a bracket like so. Okay, now I'm going to go one better, okay, and because these are both negative, I am also going to factor out minus 1. So that puts a minus at the front of the bracket. And then I can have, well, if I divide this by minus x, I'm going to have 5 root 2. And if I divide that by minus x, I'm going to have plus 4. So it keeps what is in the bracket as positive. Okay, and I've pulled the minus sign out, and so this is in as neat a form as I can write my answer.